Welcome to EDU World Space.
All right, guys, we're doing problem number 94 of Chapter 9 in Chemistry Essential Science. So in your textbook, there are two compounds of the formula P2NH3, 2Cl2. One is called cispla, which is on the left, and transpla, which is on the right. So which compound has a non-zero dipole moment? So let's look at our structures and draw our dipole moments, which our dipole moments are going to be connected towards our nitrogen, and they're going to be directed towards our chlorine. All right, so let's look at transplant. So when transplant, you have dipoling on ammonia, and you also have dipole on ammonia. They're each pulling the same strength at opposite ends, so those dipole moments are canceling out. And you see the same dynamic with chlorine pulling in one direction and this chlorine pulling in the opposite direction. So this is going to have a dipole moment of 0. Now with this one, it's interesting. So you have chlorine pulling in one direction and NH3 pulling in the other. Similarly, you see this dynamic for the other pair as well. Chlorine and NH3 don't have this. Chlorine and nitrogen don't have the same electronegativity, so it's actually going to pull more. The electrons are going to be pulled more by the fluorine than they are by the nitrogen. So that means that these dipole moments don't cancel out. So you are going to have a non-zero dipole moment. And for cispla. Now, one of these compounds is anti-cancer drug, and one is inactive. The anti-cancer drug works by its chlorine ions undergoing a substitution reaction with nitrogen ions and DNA that are closer together, forming an N-PT-N angle of about 90 degrees. Which compound would you predict to be the anti-cancer drug? Well, first, it's important to remember that this is a square planar structure, so all of these angles are going to be 90 degrees. So let's imagine. Let me see if I can shrink this a bit. Now, imagine your cispla is going to interact with your DNA. So we have and before we do this, I'm going to show you. The answer is going to be cispla, and I'm going to show you why. So this is our cispla, where our chlorines are on the same side. So it's going to interact with our DNA. Hey, I know I suck at drawing this. Please bear with me. So we're going to have our cispla sticking onto our DNA, something along the lines of this. So you have your NH3. Okay, and so these bonds are going to stick to our DNA. Okay, and we see that our NH3 that stays as a 90-degree angle, and that's for cispla. Now let's look at the mechanism if we were looking at transpla. So let's just skip to the overall structure of our transplatin complex. And so we would have our chlorine bound to our DNA like that. We would have that substitution reaction. Now look at the angle. Now remember, this is a square planar structure. So look at the distance between our two nitrogens. So this is going to be 90 degrees. And this is also going to be 90 degrees. So that means the distance between our NH3 and the N here and the N here, that's going to be 90 degrees plus 90 degrees. So that's going to be a total of 180 degrees if we were to have our transplatin complex. And as you can, so that means that our cisplatin is going to have a NPT, a nitrogen platinum nitrogen angle of 90 degrees, while transplatin is going to have an angle of about 180 degrees. So this would mean that our cisplatin is the anti-cancer drug, because even you can see that cisplan would bind more elegantly to our DNA because the chlorines are on one side of your molecule, so it's easier to make that substitution reaction with DNA, as opposed to transplant, where you would have the chlorine on opposite sides, so it's harder to make that transition. Or rather, not transition, that substitution.